You're listening to the Cyberwire Network, powered by N2K.
And now, a word from our sponsor, SpyCloud, the cybercrime analytics leader. SpyCloud disrupts cybercrime by telling you what criminals know about your business and your customers, so you can take action to prevent ransomware, account takeover, and online fraud. SpyCloud constantly recaptures and analyzes new data from the criminal underground, including credentials, cookies, and PII siphoned from malware-infected devices. With knowledge of the specific data criminals have in hand from InfoStealer malware on managed and unmanaged devices, security teams can respond with a more efficient and effective process called post-infection remediation. Get SpyCloud's post-infection remediation guide outlining the 7 steps for preventing a malware infection from becoming a full-blown ransomware incident. Visit spycloud.com/cyberwire. That's spycloud.com/cyberwire. And we thank SpyCloud for sponsoring our show. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems of protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
Pretty much industrial control systems are all around us, right? Everything we touch is either directly controlled by one of these systems or it's fabricated by one of these systems. So an industrial control system is a bunch of peripherals that combined make a product or ship a good or a service to somebody.
That's Pascal Ackerman. He's a senior security consultant for operational technology and threat and attack simulation at Guidepoint Security. The research is titled Guidepoint Security Researcher Discovers Vulnerability in the Integrity of Common HMI Client-Server Protocol.
Think of it as pretty much the engine in your car that drives everything, that makes sure that your battery gets charged, make sure that there's hydraulic pressure for your pressured steering column and stuff like that. So these systems are controlling the process. They're industrial control systems that take care of a certain process. So there's variables like temperature, pressure that go into it, and these systems will monitor these control points, and they will make actions to keep them in a certain acceptable parameters.
And so, what is the peril here that you all are exploring?
So, as I said, these systems control a key value like a pressure or a temperature. And oftentimes they do that very well themselves, right? You set them, you said, for example, I want the temperature to be at 100 degrees Fahrenheit. Or if you go back to the resemblance to a car, I want my cruise control to stay at 60 miles an hour. So it will use sensors to look at your temperature or your speed in the car reference. And it will throttle steam pressure, or it will throttle your gas pedal in the car to stay within that value. Oftentimes, there needs to be some sort of an oversight to make sure that the process is within tolerable maximum and minimum values, and that's done with what we call an HMI or human-machine interface. So an operator will have one of these HMIs sitting in the control room or wherever he's looking at these values, and he can keep an eye on the temperature. Sometimes there's some trending on there as well that can show you outliers to see over time what your pressure or your temperature is doing. I've always been fascinated with the communication from the process to that HMI and how that works. So I started looking at it deeper and deeper, and that's how I discovered these vulnerabilities.
Well, let's walk through it together here. Can you take us through this journey? What exactly did you discover?
So as I was doing an assessment of a large manufacturer, that was doing a lot of recipe-based manufacturing. This was food and beverage, and then they sent recipes from a controller, the PLC or the programmable logical controller, which is the brain of your automation system, to an HMI. And we were taking Wireshark packet captures. So we're basically sniffing the network, looking at all the traffic, all of the data traversing the network. And I was seeing these recipe names flowing by in clear text. And that set off my curiosity bell, right? And I started looking deeper into it, and I noticed that they were tied to a particular protocol. And this was for an Allen Bradley facility. So it was what they call the live data protocol, where they basically have an HMI system with the system being a server and a client. They were communicating these recipes to each other over clear text, and that sparked the whole research project.
Well, let's continue down the path then. I mean, your curiosity is piqued. Where did you go from there?
I started looking at the Wireshark packet captures and started to push it through a Python framework called Scapy, which is really, really handy for dealing with packet captures and actually also manipulating it, some of the data, which we'll get to in a minute. So I started filtering out certain values. I was looking at, okay, when I see these clear text recipes come by, what else is on that packet? Is there anything that stands out? And I noticed that there was a certain part of the protocol always showed these clear text protocols and the clear text strings passing by. So I started looking deeper at that, and I started honing down, started filtering out that particular part of the protocol, and I noticed that pretty much any data between the server and the client in one of these HMI systems is sent over clear text.
Now, is this data that's reporting back a status? Is this data that is used to control devices? Is it both?
It's both. So one way, like I said, the operator can look at his process and look at temperatures, look at pressures, and then if he notices that something is out of whack, he can go in and change a set point. He can stop the process. He can do anything from that HMI, which is also then sent back from the client to the server in clear text.
Now, I've seen enough movies where things go horribly wrong, like Jurassic Park or something like that, where there's somebody sitting at a control panel and something starts to indicate incorrectly and they say, oh, we must have a bad sensor, and then I'll go check it out. And then they go check it out and they get eaten by a dinosaur. So is that where we're headed here, that the reliability of the information flowing back and forth is really at issue?
Yes, absolutely. Think of it as being pulled over in your car, and the cop is telling you were doing 100 miles an hour, even though your speedometer was saying you were doing 60 miles an hour. And so somebody might have tampered with your speedometer, and you're thinking you're going under the speed limit, while the police officer with his radar gun picked you at 100 miles an hour. So yes, what we're showing on the HMIs can no longer be just accepted or no longer trusted to be valid. And that's a big problem, because now the operator sees the wrong values and he might make the wrong decisions based on what he's seeing.
This episode of The Cyberwire is made possible in part by Nisos, the managed intelligence company. At Nisos, they help enterprise businesses achieve better risk insights and outcomes by delivering threat intelligence as a managed service. At Nisos, you can rely on their people, process, and technology to help you control costs while improving your defenses. They help you respond to threats faster and more effectively through assessments, monitoring, and investigations. Learn more about Nisos at nisos.com. That's NISOS.com. This episode is sponsored in part by CrowdSec. Get contextualized and actionable cyber threat intelligence fed directly to your Cortex XSOAR platform with the CrowdSec integration, now available in the Cortex marketplace. By combining CrowdSec and the power of Palo Alto Network's tools, your SOC team can avoid background noise from the internet and reduce the volume of alerts. Have more oversight and information on the attacker to make swift decisions on dismantling them. Create a more informed path to remediation and efficient processes, and much, much more. CrowdSec complements XSOAR's robust solution by including a layer of security and additional vertical context. But best of all, it gives you the data needed to free up time and resources. Visit crowdsec.net to learn more. And you went down the path in your research here to actually sort of proof of concept this man-in-the-middle technique.
Yeah, so after I saw those clear text values and passing by, which was a nice finding on itself already, I thought, what if I could manipulate these values as well and start showing something else on the screen? And that's exactly what I did. I used, again, the Scapy tool to find the packets that were interesting, look at specifics on how to change some of the values on there. The framework even makes it easy for me that once I'm done with manipulating the packet, it will do a revalidation, it will do a fix-up of the CRC on the packet, and then we'll send it off to the client. And hold and behold, I saw the values change on the HMI. So I was looking at the PLC itself, which is the source of the data. It was showing 100 degrees, and then the server in the server client HMI setup, it was showing 100 degrees. But by the time I was done manipulating the packet, the HMI was showing 2,000 degrees. So that was a successful compromise of integrity.
And you're able to do this in a way that wouldn't automatically draw attention to itself, would delay detection?
It would be so. These attacks are all based around the ability to put an attacking machine, Macaulay Linux in the write up, between the server and the client. In order to do that, we have to perform what's called ARP spoofing, which is it's really easy to detect if you have the right tools in place. So if you have like a SIM or a deep packet inspection tools installed, it will be detectable. But a lot of these facilities don't have those means in place yet.
You know, as I was reading through your research and I came to the section that talks about the potential implications, I have to admit, perhaps my twisted sense of humor was triggered. The first thing you list is panic. And while it's easy to laugh at that, I mean, the reality is that in industrial environment, that's a real problem to get people responding to something that is out of bounds for what they're used to.
Yeah, and it's valid too, because I have worked in controls and automation since 1999, and I've been out on the production field, and a lot of times these processes that have high pressure steam, high temperatures, are quick and oftentimes hard to control. An operator has to be on his toes to keep it up and to keep it going. So if anything like this happens that is way out of whack, panic might have him push the emergency button, which stops the process, and with all the consequences from doing that.
Were you surprised to see so much data being exchanged in the clear?
No, no. As I've been advocating for years now, industrial control system security was an afterthought, and that wasn't anybody's fault. It's just how it organically grew, right? When we first started seeing industrial control systems, they weren't more than a handful of devices that were tied together with serial communications, point-to-point connections. So authentication, authorization wasn't in play at those times because there was only one device that was able to connect to it. But then when the hype came to bring everything to TCP/IP stack and put everything on Ethernet, in order to be competitive and to easily have customers convert from point-to-point and serial to Ethernet, they just took those wide open protocols and they put them on Ethernet. which was already being scrutinized by attackers with Wireshark, and I think it was Ethereal at that time, tools, and the other common IT attack tools.
So what is to be done here? What are your recommendations, given everything that you've discovered here?
Ideally, I'd love to see the ICS manufacturers, the controls and automation vendors start to build in authentication or at least integrity between the parts of their offerings where this kind of communication takes place. So in the case of Rockwell Automation, it would be great if they could set up a secure channel between their server and their client. Until then, we're going to have to rely on compensating control, as we call that, because you can set up a tunnel between the client and server operating systems. So Windows will allow you to set up something called an IPsec tunnel, which encrypts all communications between the client and the server.
Yeah, it strikes me too, and correct me if my understanding is wrong, that more and more organizations are relying on these kinds of remote sensors, where you used to have perhaps a person on site at a location, or on the other side of a plant or the other side of a nation, and more of this is happening remotely, both for convenience and cost savings.
Yeah, oftentimes they use what they call a SCADA system for that. And they will have remote sensors. They have plants all across the world, and they all tie that data back to a central place. The good news is, though, that they often do that communication, that centralized model. They do that over what they call peer-to-peer VPN connections or some hub-spoke VPN architecture. So from the internet, from the public network, this is shielded off by the VPN connection. But once you're on that network, all of this data is visible.
Now, what you have outlined here is a proof of concept. Are you aware of anything like this happening in the wild, of any bad guys trying to take advantage of this sort of thing?
No, not yet.
Yeah. Seems like it's a matter of time. Sad to say.
It is sad to say, but luckily or unluckily, I don't know, attackers are still focused on ransomware. So I've read some research from a colleague researcher over. They had set up an ICS honeynet where they basically open up some ports and they made it look like they had an industrial control system sitting on the internet. And he stated that over the 6 or 7 months they had that open, they had no really targeted attacks on the ICS systems, but mostly it was ransomware or malware trying to take over the network. So until that changes, stuff like this is it's probably not that critical to look after yet.
Our thanks to Pascal Ackerman from Guidepoint Security for joining us. The research is titled Guidepoint Security Researcher Discovers Vulnerability in the Integrity of Common HMI Client-Server Protocol. We'll have a link in the show notes.
Arm your team with the latest news and trends in the evolving cybersecurity landscape with CyberWire Pro Enterprise. Our unlimited pro content will allow you and your team to accelerate and sustain cybersecurity awareness and knowledge. Get access to searchable and accessible news in cybersecurity, business, policy, privacy, disinformation, and more. Find out about our education and military discounts by inquiring at thecyberwire.com/pro.
The CyberWire Research Saturday podcast is a production of N2K Networks, proudly produced in Maryland out of the startup studios of Data Tribe, where they're co-building the next generation of cybersecurity teams and technologies. This episode was produced by Liz Irvin and senior producer Jennifer Iben. Our mixer is Elliot Peltzman. Our executive editor is Peter Kilpie, and I'm Dave Bittner. Thanks for listening.